OCR A, A-level physics, and this is the fourth video on magnetic fields. And this video is about transformers. So look at this, we've got a 12 volt AC power supply. So a 12 volt AC power supply supplying a 12 volt bulb, no problem, the bulb is nice and bright. No problem there whatsoever. But look at this now. The bulb is quite a distance away, okay? And we need to transmit the electricity over a long distance. So we're going to have some electricity supply cables. Problem is now the bulb is dim. Why is it dim? Because we're losing a lot of power. Yes, the bulb isn't actually getting 12 volts. We're losing voltage because of the resistance of the cables. Yeah, if you actually touch the cables, they would feel warm. Okay, if we need to transmit electricity over a long distance, then a lot of energy is transferred as heat in the power lines, so it's not very efficient. However, what we can do is if we step up the voltage, if we make the voltage bigger, so we're keeping the power the same, but we're making the voltage bigger. So we step up the voltage from 12 in this case to 240. So we've made it 20 times bigger. And if you do this, I suggest you don't touch the power lines now. You'll get a little bit of a shock. The bulb doesn't want 240 volts, so we have to step it down again. So we make the voltage smaller again before it gets to the bulb. But the result of this is that the bulb is nice and bright. It's much more efficient. We have lost a lot less energy. Now, why? Because for the same power, remember power is voltage times current, for the same power, bigger voltage means that we need less current, and so we lose less I squared R, less power loss in the cables. How does a transformer work? I remember at GCSE this was quite a common question. Worth learning again. We put an AC voltage across the primary coil. Then an AC current flows in the primary coil. And then we get an alternating magnetic field in this iron core. So in the iron core, there isn't any electricity in the iron core. It's magnetism, it's flux, sloshing backwards and forwards. Yeah, an alternating magnetic field in the iron core, which is linking the two coils. So we get an AC EMF induced in the secondary coil. Basically Faraday's law. Now, to work out voltages and things, it all depends on the number of turns, and Vp over Vs equals Np over Ns. Basically, what that means is that if the number of turns gets bigger, then the voltage gets bigger, and that's step up. If the number of turns gets smaller, then the voltage gets smaller, and that's step down. In fact, if the number of turns gets bigger, if it's 10 times bigger, the voltage is 10 times bigger. Yeah, and that's all I do. I work out the ratio. And if you work out the ratio, you can work out your numbers of turns or your voltages or whatever. Have a go at these two questions here. Should be pretty straightforward. And the answers are in 3, 2, 1. There you go. Now, if a transformer was 100% efficient, now they are actually very, very efficient. There's something like 98% efficient because there aren't any moving parts. And we will always assume that they are 100% efficient. Then the power in equals the power out. So as I said, big voltage, small current. So Vp IP equals Vs Is. Yes, so that means that if the voltage is getting bigger, then the current is getting smaller. Just remember, if the voltage gets 20 times bigger, then the current will be 20 times smaller, etc. And having done that, have a go at this. And I'll show you the answer in 3, 2, 1. There you go. Now, there are one or two ways that you can lose energy in a transformer. Alternating flux. Remember, we've got this magnetism sloshing round in the iron core. Now, what you might get in the iron core, because iron is a good conductor, is that you might get EMFs induced in the iron core, and they might produce currents, which we call eddy currents. An eddy current in a river is like a sloshy round little whirlpool current in a river. Yeah, and we might get these eddy currents flowing inside the iron, and that would reduce the efficiency of the transformer. Why? Because from Lenz's law, they're going to oppose the magnetic field, yeah, or the change in the magnetic field. And also the eddy currents will have a heating effect, so the iron core will get hot. So how do we minimize eddy currents? Is we laminate the core. And that means that the iron core isn't solid iron, it's lots and lots of slices of iron with some kind of insulating glue between them. So it's a laminated iron core, and that reduces eddy currents, and that makes the transformer more efficient. We'll also lose a little bit of energy as heat in the coils. So these power transformers are made of thick copper wire so that they have a small resistance, so we don't lose a lot of heat energy, I²R, in the coils themselves. Last question, have a go at this. And the answer is in 3, 2, 1. There you go.